Okay, I guess we'll start. Howard, start recording.
It's already.
If anyone has their
It's,
what?
it's already recording.
Okay. If anyone has their homework from yesterday, and wants to like share it, then share it, and then we'll grade it. Like we'll go over it. Not really grade it, but just go over it. If anyone wants to share their homework.
I already got some for yesterday, so
Okay, we can go over some of them for qualitative data sheet. Open them up.
Yeah,
Just like don't say who it was, maybe in case they don't want to know. I don't know. Or you can. Yeah, honestly.
Oh, I just. Tomorrow's July 4th, huh? Oh, okay.
okay. So should I go over it now?
Yeah, sure.
I think it'll be better if I do it like privately. So I'm
No,
going.
just go over like just blank out the name and just go over the entire like go over it in general so other people can also learn from the stuff. Like, is there a way to like blank out the name? Like just delete it or something?
Yeah, I think I'll just go with that.
Yeah.
Hold up, it needs to load. All right. All right. So I'm gonna share my screen like now, okay? Oh, hold up. Yep, there we go. All right, you guys can see my screen, right?
Yeah, we can see it.
Okay, hold on. Ah. Whoa, no. Louder. Trying to do something, but like mixed results. Okay, so I'll just leave that on the top, okay? Just cause. All right. Here, let me just check again. You guys can all see my screen. Yeah, you should be able to. Okay, so for the procedure, I have a few comments written here for what they did. So, the qualitative data. On the before for this procedure, what they did, they talked about this person talked about what they how they came up with their idea for maximum consistency. That is a good idea, but what I find like kind of weird is that if you do that, the judges or proctors might take that as a sign of like earlier, like, oh, you had to like decide to make your experiment more consistent. So for this procedure before, I wouldn't exactly say this. Instead of saying we found that this doing this stuff would make it the most accurate, what I would say is that we figured out who would like record the data, who would talk about all that, who would throw the planes themselves. And sorry about my voice, I literally just woke up. And then so the procedure during for this person, they talked about the human inaccuracies a lot and talk and how that could be slightly off. So the qualitative data, I want you guys all to understand that this isn't a place where you talk about what you did wrong. This is also a place where you talk about what you did right. So if you did something right that you want to talk about, this is the place to do it. So say if you like caught the ball at the top before measuring it, then that would be something to say here. But you don't want to explain in the qualitative like data that we did something wrong. That you could, but that's not recommended. And of course, it's gonna support the possible experimental errors. But unlike something like the CER, you don't need evidence for that. So their judges are basically going. That's like an individual section. There's no need to like quote unquote help it. And I saw the same thing for the results for this person, and same things as this point really. And then for the results we had a, it talks about a clear correlation. You guys can read this, like a clear correlation to the hypothesis. And this is talk, this section, what they did is talk about why. And that goes a long ways to help that part three. And I know it is part three helping part three because you're going to be helping yourself. But if you do this after part three, this is really going to help you later on, because instead of talking about the quantitative data on something like sorry. Instead of talking about the quantitative data on something for the data trend CER, you can also notice you can also use this qualitative data, and that's going to strengthen your argument further, getting the 6 points for that CER. So yeah, that's about it for this person. Let me check if I got any more. Yeah. All right. Hold on.
Yeah, part three normally has CER.
Mm-hmm. Okay, so this one I haven't been able to get to yet, but actually, hold on. All right. Is the right one? Yeah, that's the right one. Okay, so for this person, what they did, they talked about they talk. This is what I mean by like a good before procedure. Before conducting our experiment, we chose who would be throwing the paper and what height and the measurements. So this is essentially choosing the exact constant like values. Like for the constants and control variables, you guys should have said the person throwing the plane, the height it was dropped, and the height it was like thrown from, and and then the distance as the independent variable. So here it's talking about who does what, and I just find that pretty good. And this could go to support your what is it, this could go to support your independent and dependent variables and all that. So during the experiment, we made sure to follow our procedures as closely as possible and threw them one time at a time and picked them up after one person recorded the data. So the reason this is important is because if you don't throw it one at a time, you could say that there was like some when you threw it once, there was some like a sort of cooldown for your hand. So when you threw it again, and you could see that there's an inaccuracy there. So by telling us, the like reader of this experiment, that they did this, we know that they did it as accurately as they could. And now we were able to very quickly complete an experiment and record the data. This was I would say it's like good and bad, because of course you're talking about that it's good, like you're able to complete the experiment quickly, so that could maybe go towards a little bit inconsistency, or it could go towards consistency, as oh we could finish it so quickly because we were like that consistent and that productive in the short time that we used it. And the data made sense and had a positive correlation. Rather than the other one where we saw correlation, this one says positive correlation. So they're basically advancing the data trend, the CER later, so that the only thing you really can say there is the data trend had a positive correlation overall. And again, this is helping you support the data part, the evidence for the CER of the data trend. So this was a pretty good example. I'm not going to grade it, like give points on it. Maybe I'll do that later. So yeah, that's all I really got.
Adash, uh, or she,
Yeah.
he
Ashik.
finished.
Yeah, I know. Ashik, do you have any more of the
Yeah, no,
things?
I only got two, so maybe
Okay, then I guess
Oh,
we'll just go back to the our experiment from yesterday.
mhm.
Hold up, wait. I think I put up the wrong one by accident. Okay, let me share.
Oh my god, I have way too many classes.
Okay, so this is the sample experiment we were doing from yesterday. So, qualitative data, Ashik, Ashik, share, and then, since you did qualitative data there, just show how we could use that to relate to this experiment. Here, you share your screen.
Yeah.
And then,
Rather than writing something because that could take like 5 minutes, I'll just use what I think best from the two examples that they got yesterday. Okay?
yeah, okay.
So like
Okay, we're not actually gonna write the qualitative data, Ashik's just kind of gonna explain it.
I'll be using I'll be using one of your guys' examples. ED sample experiment. So you guys can see my screen, right? So for the procedure, like we said, for the procedure before, what you want to highlight is that like, oh, we chose who we're gonna we chose all the rows. And then you're just gonna want to like emphasize on that because that's not enough. You can make it fancy, you can make it longer, or you can do whatever you want. But this is gonna be like the beginning part of your before procedure, and then if there's anything else, like before the procedure, we decided on like what to use instead of, and then we also like we chose all of the equipment we are going to use. And so it's basically just going to come down for the before procedure to these two. And now to the procedure during. This is the place where you hear like, from fourth, fifth, and sixth grade, like qualitative data. What happened? What words can it describe the course of the experiment? What five senses can you get? Now, more often than not, you're not going to get smell because obviously. So for here, I'm going to go to this. So I'm just gonna copy and paste this, and then, like I said, this it's pretty good. So during the experiment, we made sure to follow the procedures as closely as possible. And another thing you could say here is this helped us prove the natural consistency of the I don't know, experiment, and then just emphasize on that. And for the results during, you want to talk about your you can talk about what like your human inaccuracies, and like all that. And you can also because I'm talking about the natural consistency here, during the results before you can also talk about the like what is it, the human inaccuracies. That'll be like a good thing. And then for the after results, what you want to do is highlight the results. And if it was these uh, these supported slash rejected our hypothesis. You wanna put this thing. I'm sorry if it's a bit bright. You want to put this thing inside here somewhere. You see, like here you're talking about a correlation to the hypothesis. So we know that you're referring back to the hypothesis, but we don't know if it's supported or rejected. And then for you can use, and then here you're talking, you can like, that's really it for this part. Of course, it's gonna take longer than like how much did I spend on it? I took like 2 minutes. Of course, it's gonna take longer than that because I copy and pasted. And you might want to write some more stuff. See if here. Let me just talk about what you might want to write if you don't do that. So for the results before here, you're just going to want to highlight your predictions. Yeah. And for the procedure after, you're going to want to talk about your cleanup process and like putting away everything. And like if you're working with water, if some spill during the course of the experiment, so like
Maybe you could also talk about like reflecting on your procedure, almost like what you could have changed and made better or something like that.
Yeah. Sorry. Yeah, this is gonna be the main like thing of your things. Sorry, this is gonna be the main portion of your it's gonna be the main portion of your CER. So yeah, reflecting. So that's about it for the qualitative data. You guys can move on to the quantitative data. Should I explain this too? Okay, I'm just gonna go to the quantitative data. Okay. So that'd be like, oh wait, no, I forgot it. I forgot a column. Delete column, column. I forgot what I do.
Ashik, I think we already did quantitative.
Did we?
Yeah.
Did we do it above? Oh yeah, we already did it above. Never mind. Never mind then. But for the experiment, like what you're gonna see on comp is this. Yeah. You're usually gonna see the qualitative data before the quantitative data. And one thing you could do is just like if you so most of the time part 2 and part 3 are going to interact with the thing, right? With the like result with the procedure before, right? So you could do this part early because otherwise your portion of the thing for this part for part 1 is to do this qualitative and quantitative. So any head start that you can get is going to be good. And if you know, and like if you have a few scientific concepts in the back of your mind such that you know like or you can estimate what these the results are around gonna be around, like if something has more mass and it's in water, then it's gonna sink faster than something with less mass. And if something with even less mass might just like float, if you know like those like basic stuff, then you can get an idea of what the results are going to look like, and you can write part of this early. I don't recommend writing all of it early, but you need to write some of this early. Okay. So like here, even before the procedure is written, this stuff should be like done because this stuff relies on your talking and your materials. And this is just like, if you know your experiment, you can just use like the materials like they give you. So that's about, so that's like some tips for this part. Now, the next part is Howard, so I'll pass it over to him.
Okay. So wait. Okay. So the people actually do the assignment though.
I have stuff from 3 people.
Oh, okay. Then I'm gonna start share screen then. Okay.
Yeah.
How next is errors, right? So just explain to them errors and then
No,
here, wait,
next
let me
is
post
the
a link to this
graph.
in the chat so you can go to it.
No, it's a graph, isn't it?
No, the link to the document, like the ED document.
Yeah, thanks.
We did graph yesterday.
Yeah, we did.
By accident, because like we forgot qualitative data, so we did graph yesterday.
Oh, really? Well, I'm gonna have to write the. Oh, okay. So possible experimental errors.
Here, wait, let me pull up the other thing, and then you can explain it to them, and then we'll show the format, and then they give examples.
Guys, we're missing statistics.
So like the first thing for possible.
Oh wait, stats.
You didn't do.
Do we
I
have
mean,
stats?
I know part two, but like,
Okay, we have to use stats still, my bad. Okay. Who does stats? Howard, you do stats, right?
Oh my god. Okay, so statistics is actually like pretty easy if I can insert a table. The only hard part about it is how many different things are there for statistics again? There's 1, 2, 3, 4,
There's
5,
mean, mode, median, range, minimum, maximum.
6.
You can, yeah, and standard deviation if you want, but like we're too lazy, don't do
That's
it
a
right
waste
now.
of time. The judges don't even like look at it.
Median.
I mean, it's good for your CDRs, because rather than using like range to explain inconsistencies and stuff like that,
Adar,
it's much more clear if you use standard deviation.
Yeah, but it takes so much time. Is it worth it?
Adarsh, I forgot what part one does.
Yeah.
What does it do again?
Part 1?
Yeah.
Part 1 does hypothesis, a statement of problem, variables, conclusion, and application recommendation for further use.
Right. Okay.
Oh, so basically, for like, it's pretty easy to calculate all this stuff. The only issue is just when it comes to showing your work. I'm not gonna. Should I calculate all that for you, or? Adele, should I calculate it?
Calculate the statistics.
Yeah.
I mean, just do like a few. I made the numbers pretty easy, I'm pretty sure, for calculation. So
Okay, no, she can do the she can fill in the calculations, but the key thing is that
simple calculations.
the key thing of it's not the like the calculations themselves. It's actually showing your work, because judges it's actually pretty. So how I like to show my work is that I would just list the numbers. I would just list the numbers like what's our data again? Like for one of the trials, whatever. I'm just gonna make up numbers 4, 5, 4, 3, 4. If these are the numbers I see, I just gotta like, oh my god, the font is so small. This doesn't work out. If it's like this, I will just like point an arrow to point minimum and maximum, and then that's pretty. And then I'll just write least, right here, least, or minimum, and then you can do maximum. You don't. It doesn't really matter what you label them as, maximum. And then basically what this does, it gives you a shortcut to show your work. Like it's just a shortcut. Like judges, it saves you all the time you need, because after this, all you have to do is just point out that circle like the numbers. Like it's a lot easier to do this when it's not on like online, but I would just circle the number and say this is the. I would just circle the number and I would just say this is the least one, or I'd circle this or I'd circle 4 to represent. Actually, JK, I screwed up like how to write it. 3, 4, and then basically all you have to do in this case is that you just wait. Ashik, what are you doing? All you have to do in this case is that you just gotta put this thing for median, put this thing for maximum, put this thing for minimum, and to calculate average, you can just like you have to manually show your work for that one. For that one, you just do 3. You just do 3 plus 4 plus 4, and then you have like the divided by. It's pretend like this line could actually walk divided by 3, and then you would just make a is equivalent to what what is this equivalent to? 11 divided by 3, which is like, someone can do the math for that. That's basically how you would calculate the averages. In the range, you would just draw two of these circles. That's all you do. You just grab another circle like this, and then you would just point. And then how it's very cheap. It's very easy to do when you're not online, but you can just like point an arrow to here, and then you can just like subtract this to 4 minus 3. You can do a 4 minus 3. You have to redraw this every time you're trying to solve it. So like you would have to redraw this for at least the minimum maximum range. You'd have to draw that for each of those scenarios, but this is just how I would like solve it in different cases, and that's pretty much it. Mode, you would just see, you would just do the same thing, like these two arrows, you would just do the same thing, just like point them away and just say repeated number, just give a little reasoning like repeated twice, repeated twice, repeated the most. You can just do that. You can just do a very simple explanation like that. That's how I would do it. And then that's how it's really easy to do this. This is the easiest method for like showing your work for an experiment. Usually it's a lot easier on paper than it looks online, basically. Like if I did this on paper, it would take like only like couple 60 seconds to do all this, but like it's all online, so like it looks difficult on here, but it's really easy on paper. Am I supposed to explain the possible experiment to errors now? Am I supposed to explain the possible experiment to errors?
Yeah, just explain yours because you're good at it. Since it's your part.
Oh my god. I literally waited so long for a response. I don't know what you get. Okay, sure. So basically, possible experiment to errors. This is actually it's easy in one way and then it's difficult in another. So basically, how I always started off is that it seems dumb, but you should always use first, second, third, because it's very easy. It makes the proctor happier that they can identify which error is which. Like they know first error, second error. Because you don't do that. You don't say like you just go my first possible experiment to error comes in the form of human error. Like you just want to there's always gonna be a human error, environmental error, like not like in like because of the like nature environment, but like actual like the work environment you're in. You could say there's many things. It comes in the form of human error, and then you could just state because we're doing paper airplanes, we could just say our paper airplane was thrown from the hand of a person who moved his or her arm a specified number of degrees to throw the paper airplane. It seems pointless to write. Some of you guys said you can't read this or something. Okay, so it seems pointless to say like yada yada how to throw it, but that's very important to get to your next part about. You can't just say like, oh, because the person is throwing it, it's going to like the data will be ruined because the person might have inaccurate throwing skills. They can't throw the same every time. You need to explain like in detail why that won't be the case. What in the case of the throwing actually affects the paper airplane, and in my case, I'm gonna say the degrees that the person's arm moves, because it's not gonna stay the same. The degrees is like not gonna stay the same. That's my number of degrees. A human is unable to replicate movement down to the nanometer, and therefore this means that a human is not able to consistently move his or her arm at a with the same angle, every time. Because the angle is what affects the flight as the paper airplane leaves the person's hand. A change in angle and a change in angle and in each trial will lead to inaccurate and thus void results. No results. Thus no. Yeah, I could say that. It doesn't really matter what grammar you put. You just gotta say it's invalid. And then my second one is always gonna be. I'm just gonna blame it. This time I'll blame it on the paper airplane. Because in the end, the paper airplane, there's many inconsistencies to it when you fold it up. There could be many inconsistencies. Like, to get a perfect paper airplane, you might have to not all these paper airplanes will be folded the same. So you can say this trial is not reflected. It cannot be compared to another, and thus makes the data not. Well, it's not like the data is not useful. It just means that you just can't compare the data with each other because these paper airplanes may have been folded differently. My second possible experimental error comes in the form of the paper airplane itself. You don't have to say the form of, but like, it just sounds higher language in the form of the paper airplane itself. When we fold three different paper airplanes to test, each paper airplane cannot be exactly the same. We do not have access to a protractor. So folds cannot be done at perfect 90 degrees. At perfect 90 degrees or whatever degree of fold one needs to fold. This means without these materials, us humans are unable to replicate an action perfectly down to the nanometer. You don't have to say nanometer, but like, it's centimeter. It's nanometer. Because in the end, you can reason that any nanometer diversion or like a little bit off can easily mean a paper airplane veers to the left or veers to the right, and thus makes the data null. Replicate an action perfectly down to a nanometer. This means that all three of these paper airplanes may have the same design, will have different designs due to inaccuracies in the fold, inaccuracies in the fold, and thus mean that when flown, it is not a fair comparison due to us testing different airplanes with different materials. Different designs may, you could just say in parentheses that different designs may lead to different aerodynamic properties that affect distance. Because it is not a fair comparison, you gotta, and it seems like I'm pointlessly going to detail, but you need to like go into detail, but like just making like first, you just gotta think of this as like a mini story. You just gotta like detail it very like keenly, because it is not comparable. Our experiment, because it is not comparable, this means that our experiment itself may be flawed. And then the second one, you always include 3. If you don't have time, only do 2. Actually, most of the competitions we actually only did 2, because the hard part about part 2 is that you don't have a lot of time to do this. In fact, part 2 it seems like you have a lot until you realize part like 3 just dumps all your work on you. Like that's pretty much happens. Part 3 always says they can't do a thing, and then they dump it to part 2. And basically that means that for part 2, you really just have to for part 2, you just gotta like, how do I put it? For part 2, there's not a lot of time, because you're the person doing the experiment, and then at the same time you have a lot to do. You have to get the data on you. Again, you have the most parts, and therefore it seems like a lot, but you have to write extremely fast. Like this thing, I don't know, proctors, they can read a lot of handwriting, I'll tell you that. So it doesn't really make a difference if your handwriting is neat or not, because I have like the messiest handwriting so it's just like speed is key, not really like how it looks on paper, because I know everyone wants to make it neat, but for something like possible experimental errors, it doesn't really make a difference if you make it neat or not. Not compare.
Shots fired.
Oh duh. You know, when you added statistics, my part really became extremely hard, because now after statistics, it takes like a lot of I had to like actually like race through all my work, and that made some things like less like good or something. The last possible was spared to error.
I mean, Howard, you make your possible experimental errors a lot longer than I did.
Well, then I get more
You
points.
need more info. Yeah, you need a lot of info for errors, like how it affected your data and bunch of other stuff as well.
And I think I get higher points. Maybe.
Okay, Howard,
Well,
keep yourself
it
on
depends
the
on the
screen.
comp.
I'm just gonna only do 2 this time.
Okay,
yeah.
wait, I'm just gonna give him homework, cause like we can't finish really anything right now. So like, let me just go here, shift enter, no, shift enter, like control, right, page break. Okay, so your homework is gonna be, everyone has to do 3 CERs for claim.
Yeah.
3 CERs for outliers, data trends, and statistics. It's the next part. It's analysis of CER. This is probably the hardest part of the entire thing. So, good luck, children. You have. So this is the statistics one. Statistics plane dense. Okay, so just copy this table. Data trend. Okay, everyone has to like finish 3 of these by Monday, because that's when we next meet. So everyone has to do these 3 CERs, and then if you need an example of how to CER, then I will post. I'll post the first overview experiment we did. Here, let me just share, copy link. Let me just put this on the like stream. I'll put the sample experiment for homework. Yeah, okay. So I put our sample experiment on there for homework reference, and then people do this thing. Like, you can follow the other thing, and then just do three CERs by Monday. So this is you have to come up with a claim about the statistics and then support that. Come up with a claim about the data trends, support that. Come up with a claim about the outliers and support that. Okay, bye people. That's it. I think that's all we have for today.
Okay, I'm gonna stop share screening then.
Yeah, stop recording.